Hello, my name is Janessa Mora, and this is Group 2's video presentation on fluid statics. Fluid statics, what are they? It is a branch of fluid mechanics that studies incompressible fluids at rest, specifically studying the conditions under which fluids are at rest in a stable equilibrium. Fluid mechanics is notably used in automobile repair. For example, the hydraulic lift, which is a device used for moving heavy objects, specifically automobiles. So how does it work? A hydraulic lift uses the force created by pressure being applied to a liquid inside a cylinder that causes the connected piston to move upwards, making it an essential tool in the automobile industry as it can make raising heavy items, i.e. cars or even trucks, a much simpler task. The principle behind how pressure works in a hydraulic lift is explained using Pascal's law. Pascal's law, formula being P equals F over A, where pressure equals force divided by area. Pressure applied to an enclosed fluid will be transmitted without a change in magnitude to every point of the fluid in the walls of the container. Some real-life applications. Pascal's law is used in hydraulic cranes, hydraulic lifts, jacks, and brake systems, which are all equipment used in automotive repair, construction, and material handling. A prime example being an excavator digging a hole.
Have you ever seen a forklift in a warehouse and actually been quite impressed by it to see how it actually would work? The science maybe behind it? Or maybe you've seen a TikTok video on your For You page regarding a hydraulic press pressing on like random objects. Well, this also has to do with the principles of fluid pressure. So, there in science, there's a law called Pascal's law, which basically stands for P equals FA. F divided by A. So P equals pressure, F equals force, and A equals area. So today, my name is Daniel, and we're gonna delve into like the world of fluid pressure and its crucial role in hydraulic systems. So now that we got the law out of the way, let's actually pretty much like work with it. So the main thing that I'm gonna show you today is gonna be a hydraulic system. So what is this thing? Let's actually explain it a little bit better. So this is a system that has an area 1 and area 2. So area 1 is significantly smaller than area 2. And to better represent what this is for, let me tell you, suppose you have your own Lamborghini and yourself, and you want to raise a heavy object of a heavy mass. So obviously you can't do this alone. You can't do it with just unless you're the Hulk or something, you can't do it by just lifting the car. So this is why the hydraulic system machine is used for. Now, let's say you work on this machine, right? Now you want to exert obviously a small force, something that you can like handle. Now you may be asking why. This is because as soon as you exert the force 1, the law of Pascal states that there is a uniform pressure on the constant machine. So when you exert that force on the area 1, there will be a pressure. Why? Because F equals PA. So now, let's say that you have a certain area as A, and there's a certain pressure, or there's a certain force. You just manipulate the equation to find your pressure. Now this pressure is going to travel on the system all the way until it meets area 2. Once it meets area 2, you can basically name it P2, but it's still the same pressure. It's important to note that it's still the same pressure. And once it reaches P2, it will interact with area 2. Now we can actually have use of the equation that I was talking about earlier, which is going to be F equals P times A. And in this case, we'll name it force 2, which is the force that will actually be exerted on the car itself. So once P2 reaches A2, like I said, it will basically multiply that uniform pressure, the pressure that was in the area 1. Let's say, I don't know how many PSIs. We can it's theoretical right now. My partner Frank will deal into like the numbers, but this is just a theoretical question. Suppose we have a uniform um, area or uniform pressure, and the area will obviously be bigger for the platform too. So now that automatically makes our force much, much greater than the force exerted on by the kid on F1. So this force will help us lift our car. And this can all be done because the system transforms the pressure or the force into pressure. And that pressure stays constant. It's important to note that it stays constant throughout the whole system, right? So now, like we mentioned before in the start of the video, how do people use these systems? So basically, the common workers can use this on car lifts, on mechanic shops. They can basically use them to stock items like at Walmart, at Sam's, any of those department stores through lifters that allow them to get like lifted up into the higher shelves, and obviously forklifts, which allow workers to basically move heavy objects. I don't know, that deal with maybe automobile industries and stuff like that. Now, I wanted to touch on a subject that deals with another uh, principle of physics, which is just a quick little rundown on the conservation of energy and the in fluid statistics. So basically, the hydraulic systems utilize mechanical energy, and there's actually a certain law that I don't want to spoil for you, but my partner will talk about it after this my section. But there's something called mechanical advantage that is utilized across the entire system. Now, this might be like this is not water. This is actually called hydraulic fluid. Now, the energy is conserved in the hydraulic system through the efficient transfer and recycling of fluid energy, minimizing energy loss and optimizing mechanical advantage. By mechanical advantage, it means that all the force that you initially applied, it could be a relatively small force and force 2, that force is going to play a bigger role in basically creating a bigger force through the utilization of uniform pressure. So, at the end of the day, energy, since it's a closed system, energy is basically conserved. Now, you might be thinking it's conserved in the fluid itself, but the conservation of energy in the system occurs actually through the transfer of mechanical energy in the hydraulic system without loss. So let's just say that the hydraulic pump converts mechanical energy from an engine or motor into hydraulic energy, right? That's just a real life example. The system itself aims to minimize energy loss, leaks, or inefficiencies. So the optimization ensures that the energy input is effectively utilized to perform work within the hydraulic system, contributing to overall energy conservation. And that is how energy is conserved in a fluid static system.
Alright, here are the components of a hydraulic lift. First we got our hydraulic pump, which generates flow within the hydraulic system by converting mechanical power into hydraulic energy. Then we have our fluid cylinders, which are a mechanical actuator that converts hydraulic energy into linear mechanical force and motion. Then we have our control valves, which enable precise regulation of fluid flow rates, pressures, directions, and allow for smooth and efficient operation of hydraulic machinery and equipment. Then we have our lifting platforms. These are mechanical devices used to raise and lower objects or personnel vertically within a controlled environment. Here we have Bernoulli's principle. It states that as the speed of a fluid increases, the pressure within the fluid decreases and vice versa. As the speed decreases and the pressure increases, this principle holds true for incompressible fluids like water and air, flowing through steady streamlined conditions. The conservation of energy. Energy conservation is a fundamental principle in physics that states that the total energy of an isolated system remains constant over time. And Bernoulli's principle is essentially a statement of the conservation of energy for flowing fluids. It states that in a steady flow, the total mechanical energy of the fluid remains constant along a streamline. Now, hydraulic pump. The hydraulic pump acts as a power source in a hydraulic system, generating pressure to operate hydraulic cylinders and lift objects. The hydraulic pump is responsible for converting mechanical energy into hydraulic energy by pressurizing hydraulic fluid. So the hydraulic pump just takes fluid from the reservoir and it runs it in a little turbine, which which the turbine flows and it starts moving the fluids to make your hydraulic energy.
Hydraulic lift operation. Hydraulic lifts have a basic principle: to go up and to go down. Going up. When going up, a pump pushes liquid into a cylinder, pushing the piston and by relation the car up. Versus going down. When going down, the valve opens and the liquid within the cylinder flows back into the reservoir, being pushed back using the gravitational force of the lifted car. Components of hydraulic lift operation: control valves and fluid flow regulation. Both examples help maintain the pressure within the hydraulic lift, allowing the machine to operate smoothly. Control valves are designed to limit the maximum pressure within the system by diverting excess fluid back to the reservoir, preventing damage to the system, while fluid flow regulation controls the fluid flows into and out of the cylinders, ensuring precise lifting and lowering. So work done in fluid static, or work in a hydraulic system. A simple hydraulic system can increase the force but cannot do more work than what is done upon it, creating a conservation of energy. Work transfers energy, and so the work output cannot exceed the work input. In many hydraulic systems, for example power brakes and bulldozers, have a motorized pump that does a majority of the work within the system, making the amount of work being done a smaller value. The equation for work is work equals force times displacement. So real-life applications of work. Examples include a hydraulic lift raising a car off of the ground, a crane moving debris off of a work site, a hydraulic press crushing items, hydraulic platforms in warehouses, and a brake system bringing a car to a stop.
All right, this is a recap of Pascal's law, Bernoulli's principle, and how they work in hydraulic systems. So in summary, both Pascal's law and Bernoulli's principle play essential roles in hydraulic systems. Pascal's law enables the transmission of pressure throughout a confined fluid, allowing for the amplification of force, while Bernoulli's principle helps optimize fluid flow and pressure distribution within a system. Together, these principles contribute to efficient and effective operation of hydraulic machinery and equipment. Conclusion, these are group members: Daniel Aguirre, Janessa Mora, and me, Frank Bear. These are some of the references I used.